All right, guys, here's some support on your spring break activity. Question number one. So, question number one says fill in the blanks below in order to justify whether or not the mapping shown represents a function. All right. Whenever you have sets like these, guys, to figure out whether it's a function, this is what you need to know. If ever you see sets that have some numbers, all right, and have some other things in your other set, all right, this would represent your x or your input, okay? And this would represent your y or your output, okay? Whenever you want to determine whether or not something like this is a function, you cannot have more than one input, all right, going to more than one output, okay? So you cannot see a line going from more than one of the things in your x, all right? You have to only see something that looks like this, all right? So again, guys, that is the only way that this would be a function, all right? If you have only one line coming from your x value, all right? That's the only way to be a function where there's only one input is going to an output, all right? You could, however, have, all right, something that looks like this. So again, you could, however, have something that looks like this, which would also be a function. Say this is going to a, b, where you have this going to here, this going to here, and this going to here. This is also a function, all right? Because for something to be a function, it can only be one to one or one to many. You cannot have more than one arrow coming from one of your x values, all right? So those are functions. What about things that are not functions? So what if you saw something that looks like this, okay? A, B, all right? Where you have more than one arrow coming from one of your x's, all right? That is not a function, all right? So again, guys, whenever you see more than one of your arrows coming from your set A or from your input or from your x's, you know that it is not a function, all right? So that too makes it not a function, even if these look like this, all right? That too, because you have more than one arrow coming from that too, that makes it not a function. So when I look at my question, is it a function or is it not? It is a function because I only have one arrow coming from each of my set A or each of my input. All right. So this one does represent a function because for each number in set A, and set A is your input, there's only one number that is going to in set B, which is your output. All right. So again, guys, just like that. Okay. So let's try another problem. All right. So for the next problem, let's erase everything. So let's erase all of these different things. Here, we're given a graph. All right. Whenever you're given a graph, guys, that's the easiest way to determine if something is a function or if it is not. All right. Because whenever you have a graph, you can use something called your vertical line test, all right? And when you use that vertical line, what you're doing is that you're drawing a straight line downwards, all right? Or a vertical line in your function. And if it hits your function more than once, then it's not a function, all right? So let's look at this one, guys. Let's see if it hits it more than once, all right? So when I look at this, guys, and I zoom in, all right, let's see if it hits my graph more than once, guys. Let's see if it hits my graph more than once. I zoom in, all right, and let's draw another vertical line because this one we're not seeing it that closely. So if I draw another vertical line, oh, that one's not as good, all right, so clear screen. If I draw another vertical line, all right, how many times is it hitting this graph? 1, 2 times. Same way for here. It's hitting it 1, 2 times. All right. So because it's hitting it twice, then it is not a function. Okay. So that's the easiest occurrence. Okay. So what if you saw something like this? Is this a function or is it not? this is not a function because it hits it how many? Twice. Okay? So, oh, not a function. I almost got that wrong. All right? So, not a function. All right? So, what about this, guys? Function or not? Function, because I only have one arrow. So, this one represents a function because for each number in set A, which is your input, there's only one number in set B, which is your output. Okay? So again, guys, that's how you answer that. And let's keep on practicing, guys, because the more you practice, the better you'll get. All right. Here we see some ordered pairs, and it's asking us which one does not represent a function. For something to be a function when you have ordered pairs, when you have numbers like these, the x values cannot repeat. All right. If the x values repeat, then it's not a function. All right. So when I look at this, does the x values repeat for this one? We have a -1, a -7, a 3, a -2. The x values does not repeat, so this is a function. But the question says which one is not, all right? Here I have a 7, a 1, a 4, and a 7. Here the 7s are repeating, so this is not a function. This is a function because none of the x values are repeating. This is a function because none of the x values are repeating, all right? So again, guys, try to do about 10 of these, guys. That way you can get really good at it. So is this a function or is it not? The 4 makes it not because we have 2 arrows coming from the 4. All right. So this is not a function because there's one number in set A, which is your input, that's going to multiple numbers in set B, which is your output. All right. So again, keep on practicing, guys. The more practice, the better. So which one represents a function? So you're looking for when the x values does not repeat. Here I see a -6, a 2, a -6. Function or not? Not. What makes it not? The -6. So looking at this, -4, -6, 7, -8. Function or not? Function, because nothing is repeating. What makes this not a function? The 7s. All right. What makes this not a function? The 8s. All right. So again, guys, just like that. Okay. So again, try to do about 8 to 10 of these, guys. So again, looking at this one, function or not? Not. What makes it not? The 7, because the 7 has 2 arrows coming from it. All right. So this does not, because there's one number in set A, which is your input, that's going to multiple numbers in set B, which is your output. All right. So 2 more, guys, because again, I want 10. So let's look for which one is a function. So function or not? Not. Which one makes it not? The 5s. All right. Function or not? Not. What makes it not? -3s. All right. Function or not? Not. What makes it not? The -5s. Function or not? Function. All right. And that's what the question is asking for. It's asking for function. All right. So let's do our final one, guys. So function or not, guys? We see 2 arrows coming from the -3, so not, right? Because there's one number in set A, which is your input, that's going to multiple numbers in set B, which is your output. All right. So again, guys, just like that.